Good afternoon, everyone. I want to welcome you to another statistical consulting class. Of course, the focus today is scientific writing, editing, and revising. I think what I want to showcase today is uh, what kind of strategy or approach can we use in scientific, writing that can improve on clarity and also going to have a way to improve on efficiency. Okay, imagine you've actually committed resources to research. Now, how do you communicate, you know, your findings? So what kind of scientific writing approach are you going to adopt in a way that at the end of the day, you're going to have a way to improve on clarity and efficiency? And of course, that would be the focus. So let me tell you this. The one effective, you know, a way to achieve what I just mentioned, I talk about improving clarity and efficiency. One of that is to write first from the middle. I'm going to say that again. Write first from the middle strategy. Okay, so the write first from the middle strategy is actually going to focus on the core result findings. The core result findings is the result section. Okay, the result section is data driven. Okay, and of course, I'm going to say that is one of the most essential section in the entire research body. So, like I said, you're going to focus on core scientific content first before you try to refine maybe introduction, lit and so on like that. And that was why I said writing from the middle, you're going to start from the result section. Okay. And when you take a look at the resource section, resource section, like I said, presents the core finding of the study, and you're actually going to have that in form of a tables. You're going to have that in form of a chart and figures and statistical analysis. Okay, so it's very, very crucial. Okay, so start the writing from the middle. Okay, so what is the benefit, okay, of that? Because that particular section actually serves as a foundation for the rest of the manuscript. That section is critical. Okay, it serves as a foundation for the rest. Okay, and of course, and that is the reason why we actually going to begin, writing from that. And let me tell you this, writing the result from, first, ensure that all interpretations and discussions are grounded in the actual findings, because, it will provide an opportunity for audience to be able to see what I want to interpret and what I want to base my discussions and conclusion on. Okay, so uh, and after that, the another benefit that we're actually going to have from there, it will prevent what I call bias and overstatement, because a lot of people, the audience will have opportunity to see what you base your conclusion, your interpretation, your discussion on. And after you are able to establish that, Okay, after you have established your results, okay, the next thing is to write the methodology, okay, discussion and conclusion. That will be the next. Okay, that will be the next. Now, I'm going to tell you what we do in this section, methodology, and discussion and conclusion section. Whatever materials and statistical methods that you use, okay, and of course, you're going to showcase that. And not only that, it will give you opportunity to explain to the audience the way the research was actually conducted, the way the research was conducted, including the way you collect your data, okay, the experimental design, okay, and statistical analysis. Okay, so that is in that very section. Okay, I'm actually talking about the methodology section. Okay, so the methodology section will give us the opportunity to be able to know how the analysis was conducted. Because don't forget, uh, in the result, you've already conducted analysis to have results. And of course, in the methodology section, you're just trying to tell the world how it was conducted, and not only that, you also are going to tell some other beautiful story about the way data is collected, because data collection is very, very crucial. The way you collect that, the experimental design. I remember the other time we talked about the principle of experimental design, the randomization, the blocking, the blinding, and so on, like that. Okay, so that is that, like, and the last is writing the beginning last. Okay, because if you go this way, your beginning is actually going to be fantastic. It's just like you've seen the end. Starting, writing the result section first is like you want to see the end from the beginning. I remember when I was doing my PhD work, that I started in 2012, and that eventually defended in 2016. I first try to I start from the result, because the only way, I don't want a situation whereby I'm going to, let's say for instance, I start from the beginning and I start going all the way. Maybe you spend some month doing that only to get to the result, to realize that the result is not even significant. That's a waste of time. So what I did, I started, when I developed my methodology, then I just apply, I run my analysis. When I saw that the result was good, then I went back to the beginning and so on, like that. So write the beginning last. Okay. So once the core sections are complete, the core sections are the result section and the methodology and discussion section. The moment they are complete, okay, then the next you are going to do is the introduction and the abstract. And I'm going to tell you what you need to do in introduction and what you need to do in abstract. So introduction and abstract should come last. Or if you want to arrange your or paper, of course, they're gonna be the first, right? The beginning. But you have to write them this beginning last, for and we know the reason why we're doing so. Now I'm going to go to introduction now. So we are under writing the beginning last. And writing the beginning last, we want to focus on introduction. And not only that, we want to focus on the abstract. So I'm going to talk about introduction. The introduction will frame the research problem. Of course, every research, there's always going to be research questions, right? Research questions, from research questions will be able to formulate research hypothesis. Okay. And of course, not only that, you also need to review some literature that are connected to what you are doing. Okay. Then from there, you establish your objective. You establish your aim and objective. Okay. So that is for the introduction. Now, the next is the abstract. Let me tell you this. An abstract is a core summary. It's an executive summary. You can never have a good abstract without first, establishing all those sections. Because the abstract is going to give the audience the executive summary of your findings. Okay. And that was why I said it provides a concise summary of the entire study, and is best reading after all other sections have been finalized. Without you finalizing other sections, don't go to abstract. I'm going to say that again. Without you finalizing all sections, all core sections, do not attempt to go to abstract. Because the abstract, by going to abstract, you are trying to tell the world you don't. You just want to give an executive summary of your work. Is there any question on that? Okay, so and to close that, I'm actually going to say, when researchers adopt what I call right force from the middle, which is starting from the result section, of course, it will enable them to construct what I call a well-organized and scientifically rigorous manuscript. When I say scientifically rigorous manuscript, that we minimize what I'm actually going to, inaccuracies. Because what we are targeting is how can we minimize our inefficiency in report writing. So you can minimize inefficiency in report writing if you follow, if you adopt what I call right first from the middle strategy, which is starting from the result section. Okay, so I'm actually going to move. Okay, now you choose a story before writing the result section. Don't forget, I said you're actually going to start, from the middle, and the middle here is actually the result section, because the result section is in the middle. Okay, you start from there, and of course, you need to have a story to tell. And what kind of story? Okay, you talk about, the choose the material you want to tell story about. I mean, want to tell story about tables. I mean, want to tell story about graphs. I mean, want to tell story about output. Maybe the output is maybe I wrong. Maybe I actually conducted either linear regression or logistic regression or random forest or whatever, and I have an output and actually want to tell a story about that. Okay, and then choose relevant materials. When I say relevant materials, should I talk about tables? Should I talk about graphs? Should I talk about output? Okay, then another thing you should do is order the grouped materials. Okay, do that in a systematic way, and don't forget to add notes and so on like that. Okay, now the next that I want to talk about is this: writing, revising your results section. Because we know that language, you're actually going to use language, okay, in order to do this. And I'm actually going to say that we have two different kind of language that can be used, okay? I'm actually going to, we have a result language and we have a process language. I'm going to say that again. We have a result language. We have a process language. Okay. When I say process language, okay, is a process language is like describing the way the research was conducted or the analysis was conducted. We need to avoid the use of that. what we actually need is the result language, not the process language. I'm actually going to, give you an example on how we can actually rephrase, okay, process language, to get a result language. Okay, then we're also going to lower out to how do you describe your variable, the variable you are using. You have to describe each of that. Is it continuous? Is it categorical? Does it have levels? How many levels? Is it a count? And so on like that. Then we also take care of statistical terms. We are communicating with a large audience. Some of them, they are they don't have statistical skills. How do we communicate in a way that they will understand statistical jargons and so on like that? So we got to make sure we explain that. Okay. Now avoid all intentional and causal language. I'm going to give you some example on that where we need to avoid the use of or intentional causal language. Most of the time, we normally want to encourage, when you are writing report to use, non-causal language, non-causal language. But I'm going to show you an example. But let me first start from here. Please, I need you to pay attention. I want to take that one at a time. There are two types of languages. Okay. One language, the type of languages that we have, the first one is process language. The process language is just going to tell us how you found it. Okay, how you go about the analysis. That's a process language. We're not interested in that. But we're interested in what you found. What you found is the result language. So the result language should be used, should be preferred. Okay. And I'm actually going to give you an example. Okay. You know, where somebody say we ran a regression. we ran a regression. We ran a regression is a process language. It's just telling us, the process undertaking. So instead of you to say we ran a regression, you can say a regression of Y on X reveal a significant relationship. And when you say it reveal a significant relationship, you also need to indicate, maybe the P, because the p-value is less than 0.05 level of significance. So result language is more preferred than the process language. Avoid the use of we ran a regression. That's just a process, okay, language. So instead of that, tell us what result shows. So instead of that, I'm actually going to, regression of Y on S, okay, actually reveal a significant relationship. Then I'm also going to indicate what the p-value. Oh, because the p-value is less than 0.05. Now, another process language that you should avoid using is, we made a bar chart to see if this, that. Maybe you make a bar chart for comparison, maybe because you're working with a categorical variable. But instead of you to say we made a bar chart, why can't you rephrase that to the result language? Now the result language is actually going to say that figure one, because in the bar chart, you're going to name a particular as label that as a particular figure. Maybe you label that as figure one, okay, and you're going to figure one illustrate the distribution of Y, because if the Y is the response variable, the essence of the bar chart is for us to see the frequency of a particular of that particular random variable, because the random variable here is categorical. Okay, what is the percentage in a particular group? Stuff like that. And that's why you're going to say figure one illustrates the distribution of Y, showing a clear upward trend over time, stuff like that. Okay. Now, another process language that you that you should avoid using is we replace 999 values with NA. Anytime you see 999, like a missing value, okay? But why can't we say after removing missing values, okay? You don't need to include, you don't need to say 999. With 999, you're going to confuse the audience. They don't know the meaning of 999. Okay, so instead of you to say that, you can say after removing the missing values, maybe the mean of the mean of why maybe it increases by 5% or it decreases by 5% and so on like that. Okay, now another one is, I know this is very, very common where somebody is going to say, we conducted an analysis and found, even though that's okay, but that's a process language. That is trying to tell us how you find it. Okay. So instead of you to say we conducted an analysis and find, you can say the analysis indicates that the predator is related, okay, to the response, or like a predator is having a strong relationship with the response. You can even quote what I call the coefficient of determination. Situation where your intention is if you are seeking explanatory goal. Okay. So I want to believe you now understand that you should emphasize more on result language than the process language. The process language tell us how you found it. We're not interested in how you found it, but we are more interested in what you found. So what you found is the result language. Is there any question? Go ahead. Okay. Whether we should using we and I, right? Particularly in research, we like using we, even if you are the only one that conduct the research, because we believe that nobody can conduct research in isolation without consulting or without references, stuff like that. And that's why we like the use of we. You can still use will, okay? But in the result section, okay, in the result section, if you want to, in the result section, you actually want to tell the world what you found. So in that result section, avoid the use of we, but you can use it in the other body. You get what I mean? So instead of we conducted an analysis and found, we can say analysis confirms. No, you. Now you, that is just the secret of it. So instead of, I'm just going to say, oh, the result confirm a significant association between X and Y, supporting our hypothesis. Maybe initially you set out an hypothesis because nobody goes into research with an empty mind. What led into hypothesis is a research problem. Okay, and you have an hypothesis that you want to test. Like I said, you're seeking a causal goal, you're seeking an explanatory goal, and at the end of the day, then you need to be able to say, oh, the analysis confirm, okay, an association or relationship between the variables confirming our hypothesis. Does that make sense? Okay, now supporting the hypothesis. Now, before I move away from from the use of result language, okay, I'm actually gonna highlight the benefit of using result language instead of a process language. Okay, so by shifting from process language to result language, don't forget the process language is just how you found it. The result language is what you found, right? Now, by shifting from there, the result section become more clear. Don't forget, in the first place, we were seeking for clarity. We want to improve on clarity. We also want to improve on efficiency. Okay. Now, we become more clear, more impactful, and better align with scientific report standard. Okay, it better align with scientific report standard. Okay, it's going to, lead to that. Okay, it become clearer, more impactful, and better aligned with scientific report standard. Okay, now I said something the other time. Don't forget to describe your data and your variable. A variable could be continuous, variable could be categorical, variable could be a count. Okay. Now you need to be able to describe your data. You need to describe the variables. You need to tell the world if they are missing values and so on like that. I'll give an example here where you analyze chicken weight in the chicken weight data. So the data came from a study including only one chicken breed, the Rhode Island Red. You have to indicate that so that the audience or the reader may not be generalizing for all different kind of breed of chicken. Does that make sense? Otherwise, that may amount to sweeping generalization. Now, I limited my analysis to only female chicken in the data. Okay, you have to let us know so that they don't have a generalization that you consider all categories of chickens. Then the data contains several missing values, which I remove. You have to tell us how you deal with the missing value. Okay, so and that was what I said. There are critical facts about the data and choices you made in the analysis. If you fail to mention these details, the reader could draw wrong conclusions from the study. And if a reader decided to repeat your analysis, it's not likely going to have the same results. Okay, you're actually going to have issue with repeatability. Okay, reproducibility. Where research is not reproducible, the result from such research is not binding, is not valid. Okay. Now, another thing, I've seen this a lot. Please pay attention if you want to get all the point, from in the assessment. Okay. I know some of you use a software like R and so on like that. If you are describing your variable, don't use this chick underscore WT. I know that is an acronym that you use in R for simplicity, right? Use the original variable name, chicken weight. Does that make sense? Chicken weight. Okay. And don't also forget to describe the key variables. You have to give that in detail. Most especially your outcome variable. That also called response variable. Does that make sense? Now, the next that I want to talk about, taking care with statistical terms. I said that the other time. Statistical terms like error, variance, confidence, and significant, they have their specific meaning. I just wanted to know that. Okay? When error is different from residual, there's there from variance, the confidence, and so on like that. They all have their specific meaning. Okay, so make sure that you use them precisely. Okay. And another thing I'm going to talk about, avoid synonyms that lose that precision. We always want to make sure that we have an improved precision in our research. Okay, avoid synonyms that will lose that precision. And now I'm going to give an example. Look at the way to say it. It is imprecise to say aspirin dosage is very important. That is not statistical. I'm going to say that again. Oh, aspirin dosage. Maybe you are looking at the effect of aspirin dosage on a response. Okay. Now we don't say it's very important. Okay. But what do we say instead? What we say instead is that aspirin dosage is a significant predictor of weight. Maybe you are looking at the effect of aspirin dosage on weight. Okay, when I use 2 doses, 3 doses, what is the effect of different level of doses on weight? If you find a significant result where the p-value associated with the dosage is significant, because the p-value is less than 0.05, it is imprecise to say, yeah, oh, aspirin dosage is very important. We don't say that. That will make us to lose our position. But instead, we're going to say aspirin dosage is a significant predictor of weight. Weight here is a response. Okay, and whatever statistical jargons you use, try to explain to the reader, because the reader may not understand that. Now, lastly, today I want to talk about causal language and non-causal language. You should avoid unintentional causal language. Okay, I'm going to give an example, right now about what I just, talk about. Okay, so if you take a look at the example, smoking leads to low birth weight. Okay, when in fact all we know is that smoking and birth weight are highly correlated. Let me tell you this. Cause association does not imply causation. The fact that two variables are connected or they are related does not mean that one causes the other. That is what we mean right here. So, avoid the use of a causal language like affect, have an effect, impart, influence, result in, or bring about, or give rise to, or produce, or lead to. All that should be avoided. They are classified as unintentional causal language. Okay, then what are we going to use? It is better we use non-causal language. Non-causal language like association, there's an association, or there's a relationship, or it is related, stuff like that, or there's a link. I'm going to give so many example on that. Now, the example I'm actually going to give on that, number one example that I'm actually going to give on that, instead of it to say smoking lead to low birth weight, instead of it to say that smoking lead to low birth rate, that is unintentional, causal language that should be avoided. What am I going to use? I can actually say smoking is related with low birth weight. It's better to say smoking is related, okay, to low birth rate, or is associated with low birth rate. That really makes sense, more sense. That is more correct. That is not causal. Another example I'm going to, maybe you work on the level of education, the effect of level of education on income. Instead of it to say higher education impacts income level, I'm going to say that again. Instead of it to say higher education impacts income level, why can't you say higher education is correlated with the increase of income level? Why can't you say higher education is correlated with increased income levels? Higher education is correlated with increased income levels. Okay, is different from when you say it imparts or it influences or it leads to. Avoid the use of those phrase. Those phrases, they are actually classified as unintentional causal language that shouldn't be used. Okay, another example I'm going to use is when you say air pollution results in higher asthma rates. Air pollution results in higher asthma rates. When you say results in, leads to, those are causal. You should avoid the use of that. So it is better to say that air pollution is linked to higher asthma rates, or is correlated, or is associated. The bottom line here is, okay, association does not imply causation. That's exactly what we mean. Okay. what is going to be the benefit that we're going to gain by replacing causal terms with association-based terms? What benefit are we going to gain, replacing causal terms with association based term? Your manuscript, okay, your research finding will remain scientifically precise, because you know what is going to happen if you use uh you know um or intentional causal language. It will lead to loss of precision. But if you don't use that, instead you use non-causal language, of course, your research is actually your fact finding will remain scientifically precise, and it will avoid what I call over interpreting statistical relationship. Okay, we don't want to fall into that trap where we there's something that we call uh, um, exaggeration. Yeah, you exaggerate, you overinterpret, okay, statistical relationship. Okay, so if you don't want to overinterpret statistical relationship, it is better you go with a non-causal language. Okay, so I give some example here, on resource section, what somebody was doing, trying to compare different kind of models, compare model one with model two based on the p-value, model one with one, why do you think it go, comparing model one with model two, the null hypothesis supports model one because model one is the simplest, right? The model two is complicated. Okay, when p-value is greater than 0.05, you are not going to reject model one. The next, you compare model one with model three. It got a p-value of 0.04, which means model 3 is fantastic. Okay, it rejected model 1. Then we compare model 3 with model 4, and it got a p-value of 0.014, which means model 4 now is fantastic. You now compare model 4 with model 5. But comparing model 4 is a simpler model. Model 5 is complicated model, but look at the p-value. The p-value is greater than 0.05, so which means we do not necessarily need to go higher. That's what it means. So now you now compare model 4 with model 6 and still realize the p-value were not actually significant. So this is pointing to the direction of model 4. Okay, you see that now? Okay, and now this another this is a method example. Okay, just trying to then this is introduction example. Okay, then conclusion example. Okay, so take a look and read all of that. In case you need more references, you can read Nolan and Stahl 2021 Communicating with Data, The Art of Writing for Data Science, Oxford University Press. Okay, this is where I'm actually going to stop today. Is there any question before I go today? Is there any question? Is there any question before I go today? Okay, next week is spring break. Make sure you enjoy your spring break. Stay safe. Okay, see you later. Bye for now, everyone.